What is a capacitor? A capacitor is a device that stores electrical energy. It is one of the most important components in many electronic circuits. When electricity flows into a capacitor, it holds the electrical energy and releases it when needed. Think of it as a small battery, but instead of storing energy in chemicals, it stores energy in an electric field. Capacitors are used to regulate voltage, smooth out fluctuations in power, and store energy for later use. Structure of a capacitor. A basic capacitor is made up of three main parts. First, we have two conductive plates. These plates are usually made of metal and are called electrodes. They don't touch each other. Second, some dielectric material. Between the two plates is a non-conductive material called the dielectric. This can be air, plastic, ceramic, or other insulating materials. The dielectric material helps increase the capacitor's ability to store energy. Third, the leads. These are wires that connect the capacitor to the rest of the circuit. The size, shape, and material of the plates and dielectric affect how much energy the capacitor can store. This ability to store energy is called capacitance, and it's measured in farads. Most capacitors you'll see in everyday electronics are measured in microfarads. Consider that a microfarad is the millionth part of a farad. How a capacitor charges. When a capacitor is connected to a power source, like a battery, electric current flows into the capacitor. Here's how it happens. First, electrons flow from the battery into one of the plates, creating a negative charge on that plate. Then, the other plate becomes positively charged because it loses electrons. Next, the dielectric between the plates stops the electrons from crossing directly to the other plate. This creates an electric field between the plates. Lastly, as the charges build up, the capacitor stores energy in this electric field. The capacitor will continue to charge until the voltage across its plates is equal to the voltage of the power source. At this point, no more current flows into the capacitor, and it is considered fully charged. How a capacitor discharges. When the power source is removed and the capacitor is connected to a different part of the circuit, it starts to discharge. First, the electrons from the negatively charged plate move back toward the positively charged plate. Then, the electric field between the plates collapses, and the stored energy is released into the circuit. Finally, this flow of electrons provides power to the circuit for a brief time, depending on the size of the capacitor and the needs of the circuit. Discharging happens quickly, compared to charging, which is why capacitors are useful for delivering short bursts of energy. Types of capacitors. There are several types of capacitors, each with different properties and uses. The most common capacitors are ceramic, electrolytic, and film. Ceramic capacitors are small and inexpensive, and are often used in electronic devices for high-frequency circuits. They have a low capacitance but can handle high voltages. Electrolytic capacitors have a larger capacitance so they can store more energy. They are commonly used in power supplies to smooth out the flow of electricity. However, they are polarized, which means they must be connected in the correct direction. Lastly, film capacitors use a plastic film as the dielectric and are very stable over time. They are commonly used in audio equipment, motors, and high-voltage circuits. Each type of capacitor works based on the same principles of capacitance and voltage, but they are designed for different applications depending on their size, voltage rating, and reliability. Capacitance and voltage. The amount of energy a capacitor can store depends on two things: capacitance and voltage. Capacitance is a measure of how much charge a capacitor can hold for a given voltage. Larger capacitance means the capacitor can store more energy. For example, an electrolytic capacitor with 100 microfarad of capacitance can store more energy than a ceramic capacitor with only 1 microfarad. Voltage, on the other hand, is the invisible force that pushes the electrons through the circuit. Capacitors are rated for a maximum voltage. If you exceed this voltage, the dielectric material may break down, causing the capacitor to fail. Key real-life applications of capacitors. Capacitors are used in many everyday devices and applications. Let's look at a few important uses. 1. Power factor correction. In large electrical systems, capacitors help improve energy efficiency by correcting the power factor. The power factor measures how efficiently electrical power is used. If the power factor is too low, energy is wasted. Capacitors store and release energy in a way that helps balance the power, reducing waste and lowering electricity bills. 2. Energy storage. Capacitors can store energy and release it quickly when needed. For example, in camera flashes, a capacitor stores energy from the battery and releases it all at once to create a bright flash of light. Capacitors are also used in some types of batteries to provide short bursts of power in electric vehicles. 3. Signal coupling. In communication systems like radios and TVs, capacitors are used to separate AC signals from DC signals. This is called signal coupling. Capacitors allow the AC signals to pass through while blocking the DC signals, ensuring that the right signals reach the next part of the circuit. 4. Timing circuits. These are circuits that control the timing of operations in devices like clocks, timers, and oscillators. In these circuits, the time it takes for a capacitor to charge or discharge is used to measure how long an event lasts. For example, in a blinking LED, a capacitor controls how long the light stays on and off. In conclusion, capacitors are essential components in many electrical and electronic systems. They store energy, help smooth out voltage fluctuations, and manage timing in circuits. From small devices like smartphones to large industrial machines, capacitors play a crucial role in ensuring that electrical systems work efficiently and reliably. Understanding how capacitors charge and discharge, the different types available, and their applications will help you appreciate the critical role they play in modern technology. Whether it's improving energy efficiency or making sure your favorite gadgets work smoothly, capacitors are all around us, quietly doing their job.